Okay, hi Year 6, my second maths video for you, linked to your My Maths, which you have had set today, and it's due on Monday, so you've got a piece to do today and a piece to do on Monday. I don't expect you to do it over the weekend. First part is parts of a circle, which we haven't done before, so that is new for you, and then angle reasoning, which is revision. We have done that, so it's a bit of recapping, okay, and also going to remind you about checking out. So, first part then, looking at parts of a circle. Well, three words here that we haven't come across before. You might already know. We've got circumference, radius, and diameter. And what I need to point out is that here is my circle, okay? And at the centre, the middle of the circle is always the centre. Okay, so sometimes you're asked to label that as well, but the centre is always smack bang in the middle of the circle. Now, circumference there, what do we think that means? Well, you might remember from reading last year, circumnavigate, and you may also know that the prefix circum means around, okay? So if we are circumnavigating, we're going all the way around, well, circumference of a circle is all the way around. So here is my circumference. So the circumference is basically a synonym for perimeter, okay? So it's a circumference is a synonym for perimeter. It means the same thing, but we don't say the perimeter of a circle. Don't ask me why. We say circumference. I suppose it's like going round part, okay? So circumference is all the way around the outside. And when you go to GCSE level, you'll learn how to calculate the circumference. But for now, you just need to know the circumference is the outside of a circle, okay? You also need to know what the radius is. Now, the radius links to the centre, okay? The radius of your circle goes from here to here, okay? Or it could go from there to there, it could go from there to there. Basically, it goes all the way around, but it touches the circle, the outside, the circumference, and it always touches the centre of the circle as well, okay? So that is your radius. Now, the diameter is very similar, except the diameter goes, if I do it in green, the diameter goes straight through. Okay, so it goes from one end exactly to the opposite end, but it goes through the centre as well. Now, some of you will be thinking, oh, hold on a minute, that looks a bit like the radius. Well, it is very similar to the radius, except the diameter is twice the radius, because if you look here, I can move my diameter and I can make two of them, which is there. If I clone that and I can move that back again, and it attaches directly there. So you'll see that the two lots of the radius makes the diameter. So the radius is equal to half of the diameter, or in other words, the diameter is two lots of the radius. Okay, so diameter all the way through, and your radius is half of your diameter. It goes from this point to this point, okay, whereas the diameter goes all the way through. And again, you can flip your diameter around. It can go this way like your radius did, as long as it goes through the centre from one end to the other. That is your diameter. Okay, so it's basically the width of the circle, and your radius is half of that width, half of the diameter. So you can then calculate them, okay? Because you'll end up getting questions like this. And what you've got is a clock face has a diameter of 76. So I know I've got a clock with a diameter of 76. So that's this all the way through the centre. That is 76. And it wants me to work out the radius. Well, the radius is half of the diameter. So the radius would only be this part. So I need to do half of 76. Well, half of 70 is 35. Half of 6 is 3. Add those together gives me a radius of 38 centimeters there. Okay, that's all it's asking you for, nice and simple. Then you get a slightly more complicated question like this, where you've got the radius of each circle is 9. Okay, so this part here is 9, that part there is also 9. Oh, now I can work out my diameter. My diameter is two lots of the radius. Well, my diameter there is 18 then, which means this one here has also got a diameter of 18 because the radius is 9. Well, then my total length of my rectangle going along here then is going to be 36, okay? And going down this way, we know that the radius is 9, so that there is also 9, okay? That is 9, that is 9, okay? But we only need to have this part going down, so that's 2 9s, which is going to be 18 centimeters. So I know the length of my rectangle is 36, and my width is 18 Okay, so it looks a bit more complicated, but actually break it down, write on there what you know. It's quite straightforward. Now the bicycle wheel has a diameter of 47. Well, diameter is all the way along, so we can quite easily work out the radius by halving that. So that's a really straightforward question. Okay, this one's slightly harder. We've got a yellow circle is placed in the middle of the blue circle. The radius of the blue circle, so going all the way along here, is equal to 11.7. And the radius of the yellow circle, so if I do that one in green, so the radius of the yellow circle is equal to 3.9, and it then wants the distance, which is this extra bit there, okay, between x and y, so the outside of the yellow to the outside of the blue, that's the distance x, y. Well, if I know the red line is equal to 11.7, and I know the green line is equal to 3.9, and surely this extra bit of red, because we don't want the red and green, we just want this extra bit of red, surely that's just going to be the difference of those two. So I do 11.7 take away 3.9 to leave me with my extra bit there. Okay, so 11.7 take away 3.9. I'm pretty sure Mr. Smith's arithmetic questions yesterday were linking to subtracting decimals. So 7 take 9, that's a 0. 10, 17 take 9 is 8. Can't do 0 take 3, so 10 take 3. So it should give me a distance then of 7.8 centimetres. Okay. And that's all that's asking you for. Right, jumping down here quickly to angles revisiting then. You know, here we've got a scalene, here we've got a right angle triangle. Here, because we've got two lines, it means that's isosceles. So if we know it's isosceles, we know that these two angles here are also the same, and that one would be different, but they sum to 180, as every triangle does. And here we've got a equilateral triangle. We know in an equilateral triangle, all the sides are the same, all the angles are 60 degrees. Don't just tell me they're all the same, because you won't get the mark. And here we've got quadrilateral, 4 sides or more, each of 90, so we know they sum to 360 degrees in a quadrilateral. Okay. Now, isosceles triangle here, and it wants you to find x. Well, if we know this is an isosceles triangle, there's my top angle, that's a base angle, that's a base angle, so that is 22 degrees as well. If I know this part here is 90, oh, hold on a second, if I split that apart for a second, like this, and I know therefore that this angle here is equal to 22, and I know that's 90, I can work out that part, can't I? So I can do 90, add my 22, which is 2, 9, 10, 11, 112 degrees. I then need to remember to take 112 away from 180 to work out this part. So 180, take away 112, can't do 7, 10, 8, 7, 6, that's 68 degrees. So I know this part here is 68 degrees. So if I just reattach that back for a second to there, that's 68 degrees. Well, we also know that that there is 90. So again, I can do 90, add 22, or I just know if this part here, because these two triangles, that one and this one are exactly the same, well, if this top part here is 68, x is also going to be 68 degrees. Okay, so 68 degrees. Straightforward isosceles triangle. Right, here we've got a rectangle with an equilateral triangle in the middle. I know it's equilateral because we've got three red lines suggesting that they are the same length. So if I know I've got an equilateral triangle, I know that that's 60, I know that's 60, and I know that there is 60. Now I then need to work out why. What's going to help me? Well, probably the fact that I've got a triangle there and a right angle there, and I need to work out that part then. Well, if I do this yellow line here, there, and you've already told me that that's 60, can probably, because I know this is a right angle, by the way, because it's obviously a rectangle, I know that that is a total of a right angle as well. So 60 plus something needs to make 90, this blue extra part there. Well, obviously that's 30. So I know that this angle there is 30 degrees. Now, what I've got is that is 30 here. I know that this part here is y. Okay, I've done it the wrong way, but and this one here is 90. Okay, I've drawn that triangle there. We'll then do 90 added to 30, 9, 10, 11, 120, and so I can do 180, take away 120, and that obviously then leaves me with 60 degrees, so y is equal to 60. Okay, so that's nice and easy. Now here, my maths tells you this is an isosceles triangle, so this length and this length are the same. Well, I need to work out x, okay, and I've got this part. Well, if I know that that's 70 and that's 90, I can do 70, add 90, 9, add 7, it's 160, then do 160, because I've got this specific blue triangle I'm working out first. 160 from 180 leaves me with 20, so B is 20. Well, if that's an isosceles triangle here, these two base angles are the same, so this is also 20 degrees, okay? Straightforward question, all right? Moving down, well, PQR, now it says P to Q, P to Q to R, so that's this triangle which I'm going to do in green. P to Q to R is an isosceles triangle, so they are the same length. Sorry, no, that's not quite right, actually. Actually, those two are the same length. If you look at it, that looks just about right. Okay, so that there is your top angle, and these two bases. Well, if PQR, that's also going to be 73 as well then. I need to work out x. Well, I can do 73 times by 2, which is 146 degrees. So I know these two here are 146. How can I work out this one? Well, I can do 180, take away my 146, 7, 10, 4, 7, 6, 7, 6, 5, that's 3, 34. So this angle here is 34, okay? Now, if you look, I've also got, I'm going to do this in red, a big triangle here. That there is a big triangle. So we know those big triangle, this one, with an angle here of 73. We know this here is 30. We know part of this angle I've just worked out there is 34. I can then work out this tiny little angle there of what's remaining, because I can do 30, add my 73, add my 34, okay, which is 4, 5, 6, 7, 10, 13, so that's 137. So this angle, and this part that I know is 137 degrees. So I need to now work out this final part. We know this sum to 180, so 180, take away 137, 7, 10, 3, 7, 6, 5, 4. So I know this part here, x, therefore is equal to 43 degrees. Now, I know I'm whizzing through this, so I can rewatch it back, but I've only got 15 minutes for this video to last, so I had to go through it really quickly. Okay, so hopefully that's made sense for you. I've gone through parts of a circle. Radius is half of the diameter because it's exactly halfway. We both go through the center. So the diameter is 2 lots of the radius. Circumference, circum, goes all the way around. So that's our perimeter of the circle. It's all the way around the outside. You can label them. You just need to remember the diameter is 2 lots of the radius, and the radius is half of the diameter. And we've also revisited angles as well. Okay, and how we do those. Some of you have still got to do some of your My Maths I've set you for this week, so you need to catch up with those, otherwise you're going to have a lot on there to do. If you've got any questions, obviously you can message us through Twitter, you can message us through eSchools directly, you can comment to this. Now if I quickly show you how to check out, so imagine I'm doing these questions, I don't know if they're right, whatever, but I then click mark it, that's question 1. Question 2, I do it, I mark it, okay. Obviously I haven't done particularly well there, but I mustn't then close homework. You must go to see your summary, otherwise we don't get your score. So I can now see my summary didn't do particularly well. Remember, if you don't get a happy start, more than 70%, I expect you to redo it. Okay, so you would redo. Then go finish and close. I then get your score. Okay, so good luck with that. Set, obviously, today, month, and it's due in on Friday. Good luck. Any questions, let me know. I look forward to seeing your scores. Enjoy your weekend. Hopefully it's going to be nice weather, and I'll catch up with you all on Monday. Okay, thank you.